In this video, we're just going to do two examples, both of which involve you writing a polynomial from given information. In the first set that I'm doing an example for, number 28, no calculator, straight by hand. But the other one we're going to do, I want to show you that some of these are quite possible without a calculator. So I'm going to show you that you don't need a calculator for the one they're allowing you a calculator on. So let's look at number 28. We are given that the leading coefficient of this polynomial we are to write is 2, and that we have degree 3 and the zeros -1, 3, and -5. So let's get started. We're going to write f of x. Sorry about that, I was in eraser mode. F of x equals, and our leading coefficient is 2, so it's going to hang out here and wait for everything else to catch up. And it's degree 3, and we have 3 zeros, so we can kind of forget about the fact that they gave us the degree because we're just going to use the zeros we have. And we can talk more about that if you want to ask me why they gave you that. But the zeros are -1, 3, and -5. So the factor that goes with -1 would be x plus 1. The factor that goes with +3 would be x minus 3. And the factor that goes with -5 would be x plus 5. So that is our factorized version of, or factored version of our polynomial. But the answer key is in standard form, so I'm going to show you real quickly that putting something in factored form is a little bit of work, but really no big deal, and really good practice for some of you whose algebra skills are not great right now. So we will do this set in standard form. So we're going to start by bringing the 2 down and the x plus 1, and we're going to expand the x minus 3 times x plus 5 into a quadratic trinomial. And you really, really, really want to get to the point where you can look at these and see your trinomial. So this one is x squared, because what you're really doing, and you'll get faster and faster at it the more you do it without writing it all out. So our f term is x times x, which is x squared. Our outer term is x times 5, which would be 5x. Our inner term would be minus 3x, so the sum of those two is plus 2x. And then -3 times 5, or minus 3 times plus 5, would be minus 15. So now we've got our quadratic trinomial. Well, now we have to distribute that x plus 1 onto that trinomial. So we're going to put the 2 still hanging out front, waiting to be a part of things. And when you make your parentheses here, make them really exaggerated and large, and you'll see why. We're going to distribute the x from the x plus 1 first to the quadratic trinomial, and x times x squared is x cubed. X times 2x is 2x squared. X times minus 15 is minus 15x. And then we're going to distribute the 1, but distributing a 1 means you're just going to bring all those terms into your sum. So we're going to put plus x squared lined up with the x squared term, plus 2x lined up with the x term, and then minus 15. And then from there, we're going to add all those matching terms with the 2 still waiting to be distributed, so we just keep bringing it down. And then nothing adds to the cubic term, so it stays x cubed. And then we've got 2x squared plus x squared would be plus 3x squared. And then minus 15x plus 2x would be minus 13x. And then the constant is all by itself, so we bring down minus 15. One last step to our answer, so let's go ahead and put f of x equals, and distribute the 2 as we go to get our answer, our final answer. So 2x cubed, and then 2 times 3x squared is 6x squared. And then 2 times minus 13x is minus 26x. And then 2 times minus 15 is now minus 30. And this is, sorry, trying to resize so I can put a box on our answer. It's a kind of long answer there, but that's the answer to number 28. And then we go to number 32, which is a different set. And I think you only have one of these on your assignment, but I want you to see that it's a lot simpler than you probably would have guessed. So, no clues this time, no leading coefficient, no degree. It does say in the directions that this is a cubic function, which corresponds to the fact that I have 3 zeros. So that's where we're going. Our 3 zeros are -2, 1, and 5. What we don't know here is what a is. So we'll start our first version similar to the way we did the number 28, but we don't have a 2 to hang out in front. Now it's going to be an a hanging out in front because we don't know what a is, so we're going to leave it. But the negative 2, 0, is going to contribute a factor of x plus 2. The 1, 0, is going to contribute a factor of x minus 1. And then the 5 is going to contribute a factor of x minus 5. Now, before you panic, let me just tell you, we're going to leave this answer in factored form, but I want to show you the power of working from factored form and not having to go back to standard here. Because now we're going to come back and use what you probably thought I forgot to mention, but I was holding it because it didn't give us a 0, but this is the point that's going to tell us what a is. Because what this says is that when I plug negative 1 into this polynomial, I get 24. So I'm going to replace all the x's with negative 1. And I'm going to solve for a. And if I plug negative 1 into x plus 2, I get 1. If I plug negative 1 into x minus 1, I get negative 2. If I plug negative 1 into x minus 5, I get negative 6. And when I plug negative 1 in, the result is 24. If I can get my board to work here. Alright, so then I have 1 times negative 2 times negative 6, which would be 12a, equals 24, which tells me that coincidentally a is 2. Because I divide both sides by 12, I get a is 2. So now for our final answer, all we have to do is replace a with 2, and we're done. So I have 2 times x plus 2 times x minus 1 times x minus 5. And that is the answer. And the end of this video.